Hi. So for my summative assessment 3 for my digital electronics to laboratory subject, these are the objectives. So to create an application of ADC in PIC microcontroller using MCC in MPLAB IDE. So the application that I chose was a sound editing equipment sound for sound or volume LED indicators. So just like this at the pictures, here are the knobs for the potentiometer. So potentiometers can be used in knobs and sliders such as those on this sound editing equipment here in figure 1.1. In this type of operation, potentiometers are used in controlling or editing the sound and volume of the recording. Potentiometers are a form of electrical resistors, therefore it works by controlling the resistance value. A potentiometer uses either a 2 or 3 terminal configuration. A slide wire contact is used to create a voltage divider that can be adjusted to different configurations in the recording. It is this ability to make an adjustment in position that makes it possible for the resistor to be useful in simple management tasks associated with operation just like this editing equipment. A low value in the LED indicators means that the resistance value is high and that the amplitude input in the speakers is low. On the other hand, a high value in the LED indicators means that the resistance value is low, which makes the amplitude input in the speakers high. The application will use 10 LEDs to indicate the level in the sound editing equipment. When only one LED is on, it is at its lowest value, and the highest is when all 10 LEDs are on. So to start off the application, we need to open, of course, the MPLAB X IDE application. After that, we need to create a new project, standalone project, PIC 16F18875, the controller. Project name is Summative 3. And then next, open the MCC, the MPLAB code configurator. And then save the myconfig file. Here, we're going to edit the application or the setting for the IC. So here is the pin manager. We're going to add the ADCC here at the device resources. And then here at the pin manager for the grid view, we're going to turn on input for the ADC ANX here at port RA0, and at the pin module GPIO output ports RA1 to 7 and ports RB0 to 3 to 2 rather. So those are for 10 LEDs. So here for the LEDs, let's turn off or uncheck the analog and change this input for potentiometer. And after that, we're good to check the system module. We won't change anything. And for the ADCC, everything looks good. We're not going to change anything here. Just leave it as is. And then let's generate. So generation complete. Check the main C file and the adcc.c. So let's start making the code. We need to get codes from the adcc.c file. So there, let's make the code. After clicking the build button, it's build successful. So now we'll need to transfer the code to the IC using the IPE application, MPLAB XIPE. So as the application is opening, it is important to change the power settings in this application so that we can transfer the code into the IC, because it has different power settings. So to do this, what we need to do is click on settings, advanced mode, microchip is the password. Here, check that, and 3.125. Connect and load the hex file after connection. There, and then program. And after this, programming is complete.
So here is the completed circuit for Summative Assessment 3 for the application of the sound editing equipment LED indicators. So here is the PIC 16F18875 microchip. This is the 10 kilo ohm potentiometer. These are the 220 ohm resistors, and these are the LEDs. So for the connection of the circuit, let's start here. So this wire here connected to the second pin is connected to the middle pin of the potentiometer here, the green one, the middle pin. And these wires from port 3 up to 7 here are connected to the first 6 LEDs. This is LED 1, 2, 3, 4, 5, 6. And the 4 remaining LEDs are here. 3 rather. This is for pin 33, 34, and 35. So there. And next, of course, VDD VSS, pin 11 and 12, and pin 31 and 32 connected to the positive terminal and the negative terminal for the VSS. Positive for the VDD. Here, you can see the negative side of the LEDs are connected to the ground. This wire here is just to connect these two portions here because they're not connected. So there. This is the positive supply, and this is for the negative volt for the 5-volt power supply. So let's test the circuit. So if I'm to plug in a 5-volt power supply, here is the potentiometer. It is at the most left, counterclockwise. If I'm to turn the potentiometer clockwise, oops, 1, 2, 3, go. So here is the potentiometer. It is fully turned counterclockwise. So if I'm to turn this clockwise, there. And if I'm to turn it counterclockwise, clockwise again. So as you can see, this can be used for sound editing equipment. So let's say if you are to increase the modulation of the voice or the volume, this can be an indicator of how much you are increasing there. So you will know how much you have already increased or decreased for the sound of the audio or recording or its volume.